vapor pressure. And the second property is what? Elevation in boiling point. Third property is osmotic pressure. And fourth property is depression in freezing point. So there are four colligative properties are there. So first one, we are writing the definition itself. Here you see the properties of solution. Properties of solution. This is properties of solution only, which depends on what they are going to depends on number of solute particle. This is which depends on number of solute particles irrespective to their nature is called what? Colligative properties. So these things you have to understand. That is, they are not going to depend on the nature. They can be more, they can be less, but they are depending on the number of solute particle. What are the types? If I will go for the types of colligative properties. Okay. And why do we study colligative properties? That we get to know. So first of all, you try to understand that is colligative types. First one is called RLVP. And that is relative. This is called relative lowering vapor pressure. Relative lowering vapor pressure. What do you mean by relative lowering vapor pressure? That is, if you are adding the non-volatile solute, so what will happen? The vapor pressure decrease. Related to what? This is the related to the vapor pressure of solvent. So this is called relative lowering vapor pressure that we will study later. Next one is elevation in boiling point. This is the elevation in boiling point. This is there. Elevation in boiling point. Next one is osmotic pressure. This is also there. OSMOTIC. Osmotic pressure. So it is the little bit bigger topic. Osmotic pressure. Here we will study the reverse osmosis, this all the way. And that is the last one is depression in freezing point. This is depression in freezing point. So these are whatever the point we are writing here, 4 point we wrote, that is relative lowering vapor pressure, elevation in boiling point, depression in freezing point, osmotic pressure. These all depending on what? Depending on number of solute particle. They are depending on number of solute particle. So since they are depending on number of solute particle, therefore they are known as what? Colligative properties. Okay. Let's come back to the slide here little bit for 1 minute and check these slides here, what the topic they are talking. Here you see, we have learned in section 243 that the vapor pressure of solute, okay, what the solution decreases when non-volatile solute is added to volatile solvent. Okay. So if you are adding the non-volatile solute to volatile solvent, so vapor pressure is going to be what? Decrease. That you already know. There are many properties of solution which are connected with this decrease in vapor pressure. These are relative lowering of vapor pressure of the solvent, depression in freezing point of the solvent, elevation in boiling point of the solvent, and osmotic pressure of solution. Now here they are the definition they have given. All these properties depend on number of solute particle irrespective of their nature. They are talking is respective of their nature relative to the total number of particle present in the solution. Such properties are called colligative properties. Understood? Irrespective to their nature. Are you getting this one? Yes or no?
Yes.
Here they are saying colligative from Latin word co means together. Ligare means to bind. In the following section, we will discuss these properties one by one. So first one we are talking about relative lowering vapor pressure. Okay. These properties you try to understand. Relative lowering vapor pressure. So vapor pressure, relative lowering vapor pressure means vapor pressure will decrease when non-volatile solute will be added. So here you see, we have learned in the section 2.4.3 that the vapor pressure of the solvent in solution is less than the pure solvent. Why it is saying like that? Can you explain this one, this point? Okay.
This mole fraction will be less. No? Their mole fraction is 1, here mole fraction will be less than 1. So that means that the P that means that it divided by PA will be less, because we know, sir, partial pressure P equal to vapor pressure P naught into X. There is a mole fraction. So in case the mole fraction is less, then that means that mole fraction by partial pressure will also be less. So the vapor pressure will
But
be less.
here you see that the vapor pressure of solvent, they are not talking solute. Solvent in solution is less than the pure solvent.
That is because in pure solvent that will have mole fraction 1. But when it is in a solution, that means must be having mole fraction less than 1. Otherwise, cannot be the solution.
Okay, okay. When you are adding the non-volatile solute in the solution, non-volatile you add non-volatile. So what is the surface will be taken by the non-volatile solid solute also na?
That is also. That is
This
also.
solid solute what will do? This will decrease the vapor pressure. Yes or no?
Yes, sir.
Raoult's law established that the lowering of vapor pressure depend only on the concentration of the solute particle, and it is independent on their property identity. So this line here you see the important point. Raoult's law, what they are saying, Raoult's established that the lowering of vapor pressure, whatever the decrease in vapor pressure of the solution is there, lowering of vapor pressure depends only on the concentration of solute particle. Which particle? Solute particle. And independent on their identity, that is nature. This decrease is what? Based on the solute particle only. The equation 2.20, we have to see this one. Given this established relationship between vapor pressure of the solution, mole fraction. So that is what the equation you are telling this one. This for the this is for solvent. For solvent. So for solvent, that is what is there? P1 proportional to X1. So P1 equal to P1 not X1. So this is the equation. Now, this is the less. This will be vapor pressure. This is the solvent. No? Solvent is the always it will be the more. Yes or no? Solvent. Pure solvent is always more. Pure because all the particle is going to vaporize. So what will be there, Sanoy? So delta P1. Here you see delta P1. This one, how can we write? So delta P1 is equal to, if I will write, BP of pure solvent, BPR pure solvent, BPR pure solvent, 9 minus BP of solvent in solution, BP of solvent in solution. We cannot take solute. Solute is solid solute, na? So we need not to. So pure solvent, what we can write? P1 not minus. That is P1. P1 not minus P1. P1 is here, you have to know this one. So what we can write? Delta P1, that is here P1 naught is as it is minus P1 naught X1. Can we write like that?
Yes.
Here, if you see, there will be common, we can say delta P1 is equal to 1. What the common it can be, Sanoy?
P1 not.
P1 naught. So here is what will be there? 1 minus X1. Yes or no? So
Yes.
delta P1 is equal to what will be there? Delta P1, this is divided by P1 naught is equal to 1 minus X1 is equal to what we can write? X2. Can we write 1 minus X1 is equal to X2?
Yes.
This is what the relative lowering vapor pressure. Relative lowering vapor pressure depending on mole fraction. So let us read this one. Knowing that X2 is equal to 1 minus X1. In this one they have kept. So delta P1 is equal to X2 P1 naught. In solution containing several non-volatile solute, the lowering of vapor pressure depend on the sum of the mole fraction of different solute. So this is the equation is going to be formed. Delta P1 is going to be P1 naught minus P1 divided by P1 naught. is equal to x2. Here if you go little bit more detail, so P1 naught minus P1 divided by P1 naught, and here is x2 means W2 upon M2 divided by W2 upon M2 plus W1 upon M1. In the denominator, this will be less. This will be what? Less. So what we can write here? P1 naught minus P1 upon P1 naught is equal to W2 multiply by M1 divided by M2 multiply by W1. This is. Are you getting this?
Yes.
So here you can go a little bit. Here they are saying the expression on the left hand side of the equation here, as mentioned earlier, called relative lowering vapor pressure. This is called what is relative lowering vapor pressure, and is equal to the mole fraction of solute. Mole fraction of solute means what is there? It is x2 na. x1 is solvent. x1 is solvent.
Solving.
1 is always wherever 1 is there, that is for solvent. And 2 is what is? X2 is equal to solute. So in the expression, what is there? X2 is there. So mole fraction of solute. So relative lowering vapor pressure depending on mole fraction of what? Solute. Yes or no?
Yes.
This equation already we have done this equation. So M2 is what? W2 is given mass of solute. M2 is molar mass of solute. M1 is molar mass of solvent. W1 is the given mass of solvent. So here see W1, W2 are masses, and M1, M2 are the molar masses of the solvent and solute. Means 1 is the solvent and 2 is the solute. So I am telling you once more because you may forgot these things. So here you see derivation of RLVP. RLVP. So what is there? If you are adding T1, okay, for solvent in solution, solvent in solution. So solvent in solution, that is P1 equal to P1 not X1. Equation 1. Is it okay?
Hmm.
Huh. Okay. Now, when non-volatile solute added, when non-volatile solute added, non-volatile solute added to pure solvent, then vapor pressure will increase or decrease? Then vapor pressure will, what will be there? Increase or decrease? Decreases. Decreases. Okay. So what we can write? Delta P, that is change, is equal to which one is more? That is P1 not
Hmm.
minus P1. Is it okay?
Yes.
From 1 and 2. From 1 and 2. What we can write? Delta P is equal to P1 naught minus P1 naught X1. So delta P is equal to what we can write? P1 naught we are taking common 1 minus X1. And we know, Sanoy, what we know? Do you know? X1 plus X2 is equal to 1. So X2 is equal to what is? 1 minus X1. So from here, what we can write? Delta P is equal to P1 not X2. Can you write like this?
Yes.
Here you come. Delta P upon P1 not is equal to X2. So delta P, what we can write? P1 naught minus P1. Pure solvent have more vapor pressure than the solution. And divided by P1 naught is equal to what will be there? N2 upon N1 plus N2. Now in denominator, if I will go in denominator, what will be there, Sanoy? In denominator, N1 is N2 is very, 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 very less than N1. So it can be neglected. So it can be, what we can be neglected? Yes or no? It can
Yes.
be neglected. So we can write P1 naught minus P1 upon P1 naught is equal to N2 upon N1. N2 upon N1. Is it okay?
Yes.
Now next slide.
So
So,
last slide, please. Change it.
uh, done.
No, sir.
If it is done, let me know.
Done. Done.
Done.
Yes.
Okay. So what we can write? P1 naught minus P1 divided by P1 naught is equal to, we can write W2 upon M2 upon W1 upon M1. So P1 naught minus P1 divided by P1 naught is equal to W2 into M1 divided by M2 into W1. This is there. Now, Sanoy, this is what? P1 is equal to vapor pressure of pure solvent. This is pure solvent. Now, P1 is, what is P1? Vapor pressure of solvent in solution. Okay, this is there. Next one, W2, gram mass of solute, gram mass solute. W1, gram mass of solvent, gram mass of solvent. Next one is what is there? M2, M molar mass of solute, molar mass of solute. M1, molar mass of what? Solvent. Can you understand this all?
Yes.
Okay. So, solvent. Can I erase this one?
Yes.
So we are going to solve the problem. Let us see the problem where we can find the sum of the problem. Here one problem is there, this one. Okay. This problem. So better you try to understand here only. Okay. This I will do. I am doing here. The vapor pressure, here they are saying, wait, let me reload this one. Huh. Okay. The question they have said, what is vapor pressure of pure benzene at certain temperature is 0.850. So P1 naught, how much is there? 0.850. Next one, a non-volatile, non-electrolyte solid weighing 0.5 gram. What is there? W 0.5 gram. When added to 39 gram benzene, W1 39 gram. Benzene. This is what? This is the benzene. This is the benzene. Now, molar mass 78. So, M1 is equal to 78. Now, vapor pressure of solution, then 8.4, what is there? 0.845. So, P1 is equal to 0.845. This is vapor pressure of solution. It then is 0.845 bar. What is the molar mass of solid substance? So, M2, they are asking. So, what the formula we are going to use, Sanoe? P1 naught minus P1 divided by P1 naught is equal to W2 multiply by M1 divided by M2 W1. Now, P1 naught already there how much? 0.850. 850 minus 0.845 divided by 0.850 equal to what we can write here. This one, see, W2 0.5. This is the 0.5 multiply by what will be there? M1 is 78 molar mass of benzene divided by what is there? M2 they are asking. Multiply by what they we are going to have in the W1 is 39. So you can divide, this will going to be 2 times, right? 2 times, and then you multiply, this is going to be 1. So what is, and this subtract, if you are subtracting this one, 5 it will be then 0, again 0. This one 0.005. No, this is coming divided by 0.850 equal to 1 by M2. So M2 is equal to what is there? 0.850 upon 0.005. So means 850 upon 5. So what will is going to happen? 5 1 ja 5, 5 7 ja 35, 170 gram per mole. Or you can write 170 U. Can you understand this one?
Yes, sir.
Sure.
Yes,
Can I erase this?
yes, sir.
Yes, na?
Yes, sir.
Okay. Now I'm giving you some other problem. Just you solve this problem. Is the new slide is visible to you?
Yes, sir.
Okay. Yeah, this question already we have done. This question. You read and let me know whether you read and then let me know what can be the answer. Can you read the question?
So the vapor pressure of pure benzene at certain temperature is
Hmm.
640 Hg.
Hmm.
The pressure of pure benzene.
Hmm.
Pure benzene is
Hmm.
40.
How clearly you are not reading?
And a non-volatile
Hmm.
solute
Hmm.
weighing
Hmm.
2.125 gram
Hmm.
added to
Hmm.
39 gram of benzene.
Hmm. Hmm.
Now the vapor pressure of solution is giving
Hmm. Hmm.
600 ml.
Hmm. 600 mmHg. What is the molar mass of solute? M2 they are asking. Can't you do? Okay, let us see. I am doing here. Okay. What you can do here, what you can do, these are the information. What they are saying, the vapor pressure of pure benzene at certain temperature is 640. So this is the pure means P1 naught, that is 640 mmHg. A non-volatile solute weighing that is 2175 gram added to 39 gram of benzene. How much you are adding? W term non-volatile solute 2175 gram. Where you are adding? That is 39 gram of benzene. Then the vapor pressure of solution is 600. It is reduced now. Solution reduced when you are adding the non-volatile. What is the molar mass of solute? So see here. According to which principle we have to apply? According to RLBP, relative lowering vapor pressure. What is the formula? Is there relative vapor lowering vapor pressure? P1 naught minus P1 divided by what will be there? P1 naught equal to W2 multiply by M1 divided by it is M2 multiply by the one. W1. So P1 naught how much? 640 minus how much will be there? 600 divided by 640 equal to W2 they have given 2175. 2.175 M1. M1 molar mass of benzene. This is the W1 what they are saying. If you see 39 gram of what they are saying benzene na benzene. So what will be the mm of benzene? What will be the mm of benzene? Mm of benzene C6H6. So that is 12 into 6 plus 6. So 72 plus 6 is equal to 78. So we are mentioning how much? 78. Are you getting this?
Yes, sir.
M2 they are asking. W1 they are already saying how many gram? 39 gram. So now next one you see. So something is divisible here, very clearly divisible. If you are dividing it is 2 times it is getting divided. Okay. And here if you subtracting, So it is coming 40 upon 640 equal to 2.175 multiplied by 2 upon it is M2. So here you see, this is if you are writing M2 is equal to, what will be there? M2 is equal to 2.175 multiplied by 2 multiplied by 640 divided by 40 only. So this is divisible. This is also maybe divisible. 4 1 ja 4. Nah. And 4 6 ja this one. So it is 2175 multiplied by 32. Can you multiply this one? Yes or
Yes.
no? Hmm. 2.175 multiplied by 32. 69.6. It is coming 69.6 gram per mole. 69.6 gram per mole. I am checking in the book whether it is correct or not. Yeah, 100% correct. 69.6. Okay. This is
Yes.
fully correct. Huh. So did you understand this one? Can we go move on the next question? Did you note this one?
Yes, sir. Fully. All the question answer both are.
Question I will share you, no problem. This question, can you see this question? Okay.
Yes.
Similar question are there almost, I think, same question, I think it is same question, leave it. Yeah, you can try this one. You read clearly you read the question.
The pressure of pure benzene
Hmm.
at a certain, what is
Hmm.
that, sir? Temperature,
Hmm.
200 mmHg
Hmm.
at same temperature,
Hmm.
vapor pressure of a solution
Hmm.
containing
Hmm. 2 gram non-volatile, non-electrolyte solid. So how many gram? 2 gram. So this is the W2 is equal to 2 gram. Non-volatile, non-electrolyte solid in 78 gram benzene. So 78 gram benzene means this one, 78 gram. This is benzene. Is how much there? Vapor pressure of solution 195 mmHg. So P1 is equal to 195 mmHg. Okay, little bit here the handwriting you may be finding difficulty. What is the molar mass of solid? Molar mass again they are asking M2. So this you may this you will be able to do. M1 is equal to 78. Should I do or you will do?
can.
I should do this one.
Sir, I am doing that only.
Okay, doing means that is correct one. Good only. Then you try. Otherwise I will do. Don't write the question. Question I will give you now. I will share you.
M2 equal to 100.
Do it fast, Sanoy. Where you are writing?
Not visible.
Visible, visible. Do it. Hmm. Okay. Hmm. You explain to me also how you are doing.
Sir, using that formula P1 naught minus P by P1 naught equal to W2 into M1 by M1, M2 into W1.
Okay, okay. Hmm. Hmm. 2 gram. Then molar mass of benzene. How you okay. Molar mass of benzene. Then M2. M2 they are asking.
M2 they are asking.
Yeah, M2 they are asking. W1 they have given. How many gram? 78 only. So they are divisible. Okay. Hmm. 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 2 by m2. M2 is capital M, not small m. Molar mass is always capital M. Okay. Hmm. 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 How much is coming? 80 U. 80 U is correct one. This is 100% correct. So you understood this problem, right?
Yes.
Now let's see next one. This question you can see. This is the question.
So this is not gone. So
God. Should I do or you are going to do?
let me check some papers.
Pure benzene to material. Paper pressure of pure water they have given. P1 not P1 not H2O. They have given 23.8 mmHg. mmHg. Paper pressure of pure water at 298 Kelvin is 23.8 mmHg. 50 gram of urea is dissolved in 850 gram of water. 850 gram of water. How many gram urea is going to dissolve? 50. So W2 is 50 gram. Urea dissolved in 850 gram of water. So W1 is they have given 850 gram water. 850 gram water. Calculate the vapor pressure of water for this solution. And this is the urea. So M2 urea, what is the M2? M2 means M2 of urea, M2 of that is molar mass I am writing, molar mass of solute. M2 that is molar mass of solute. This is the what? NH2, C double bond O, NH2. The how much is coming? M2 is coming 60. Okay, this one. Now M1, if you are going M1, M1 is how much? 18 gram per mole. And this is the gram per mole. This is very simple molar mass. Then what is they are asking? Calculate the vapor pressure of water for this solution. That is P1 they are asking. And its relative lowering vapor pressure. Relative lowering vapor pressure also they are asking. Relative lowering vapor pressure means P1 naught minus P1 upon P1 naught value they are also asking. These two things they are asking. So let us try to solve this one. So what we can do? P1 naught minus P1 upon P1 naught is equal to W2 into M1. W2 into M1 divided by M2 into W1. So P1 naught they have given 23.8 multiply by P1 they are asking. P1 naught 23.8 as it is. This is minus, no? This is minus. A W2 you see, W2 50 gram. W2 is 50 gram. M1 is how much? 18 gram divided by M2 60 gram. W1 W1 is 850 gram. 850 gram. Okay. Now solve this one. How can you solve? 23.8 minus P1 upon 23.8 is equal to 1010 going to be cancel out. Okay. 1010 18. Is this going to be divided somewhere? 1885. No, it is not going to divide.
not
Not divide. So, but this is going to divide, na? 3 6 ja 18. So 5 multiply by 6 divided by 850. This is also divisible. This one. How much will come? 6 upon 5 1 ja 5 and 5 5 ja 25. This one. Now, this is again going to be divisible. How much? 2 3 ja 6, 2 7 ja 14, 3 by 75. So let us rewrite here. what we can write here? That is 23.8 minus P1. 23.8 minus P1 upon 23.8 equal to, this is 3 by 75. Okay. So let us try to solve. This is also divisible. 3 2 ja 6. Yes, yeah, no. 3 2 ja 3, 5 ja 15. So again, if you are writing this one, let me write here. So 23.8 minus P1
Sir,
upon,
you scroll up the slide which sir, I was writing that whatever written on the side.
is it okay? So here will
Not
be
okay.
one.
Now okay, now okay.
So here you see what will be there. 25 in bracket 23.8 minus P1 equal to 23.8. Now solve it. So here 25 multiplied by 23.8. It is coming 595 minus 25 P1 is equal to 23.8. Now, what you can do here, 595 minus 23.8 is equal to 25 P1. This is there.
Sir,
So
for the urea mass is 60 or 69, sir.
60, 60, 60. 23.8. So it is coming 571.2 is equal to 25 P1. So P1 is equal to 571.2 divided by 25. So here 571.2 divided by 25. So it is coming how much?
Sir, here one
22.
mistake is there, I think, sir. This one. This
What, what?
one. This one mistake is there, I think.
Where? What is problem?
The 6
One.
and here is 18, so sir, this should be 3, no?
So here I wrote now.
So, sir, how here, but it is still 850.
I think I did mistake or what? 50 upon 60. 850 is as it is, I think.
That
So
should be as it is.
it should be 3, na?
Yes,
Oh,
this should be.
let me check the answer. 23.4 answer is coming. 23.4.
Hmm.
23.8. Okay. Let me do the one more calculation. 6 3 ja 18. Here is the 3.
3 should be there.
5 multiplied by 3 divided by 850. So this 3, 3 2 ja 6. This is not divisible now. Oh God. Total mistakes is become. Okay. Let me rewrite here. But not there is not too much variation is not coming.
Ah,
23.8 minus P1 upon 23.8 is equal to how much? 5 into 3 divided by 6 into 850. Is it okay?
yes.
3 2 ja 6. This one.
No, sir, why? From where you're getting 6? This 6 where you're getting from? This one?
This is what is this? This
Cancel,
one.
sir?
This is.
This
Acha,
cancel,
this is
no?
cancelled. 5 into 3, that is correct. Divided by 850. This is now correct, na?
Yes, sir. Now correct, now correct.
This will be divisible by 5. So 3
Oh,
upon 5 1 ja 5. 5.
70.
This is
170.
7 170. 170. Na? This is not divisible by 3. Not
No.
divisible. Okay. Okay, leave it. So 23.8 minus P1 divided by 23.8. Here what we can write here, 3 upon 170. Now, if
0
you
0.017.
170 here is, we are solving now. 170, 23.8 minus P1 equal to 23.8 multiplied by 3. Are you getting this?
Yes, sir.
23.8 multiplied by 170, it is coming 4046 minus 170 P1 is equal to, this is going to be 23.8 multiplied by 3, 71.4. This is 71.4. So what is going to be 4046 minus 71.4 is equal to 170 P1. So what we are going to be 4046 minus 71.4. So it is going to be 3974.6 is equal to 170 P1. So what is there? P1 is equal to 3974.6 divided by 170. So divided by 170. So now it is coming 23.38 mmHg. This is exactly they have given in the answer. 23.4 is the answer. 23.4. So this was a little bit error were coming because of the some mistake we did. Not we, I did.
No, sir, nothing like that.
Uh, Sometimes it's happen, na, that the over calculations create the problem.
This chapter especially having a lot of calculations in these exponents and
But it
powers.
is, but this is very interesting. Do you know? This chapter is very interesting. Once you are used to solve the problem, na, nothing can be good because this is the very basic numericals are there. So we got this one. Okay. Now there are another things they are asking. One more things they are asking. What they are asking? P1 we got, and then they are asking this value also they are asking relative. This is what relative lowering vapor pressure. Na. Relative means ratio. Relative means ratio. So how much it is coming? You see P1 not, you see P1 not. P1 not already 23.8. P1 just now 23.4. We got 23.4, I think. Huh? Divided by 23.8. So how much is going to be? I don't know. This is correctly we are doing now. Hmm.
It's okay, no, sir. This should be the correct answer. What else could be?
Uh, I'm just finding the answer is there or not. Relative lowering. And it's relative lowering vapor pressure also asking. So this way if you are doing now, so what will come? Point 0.4 is coming, 0.4 divided by 23.8. So zero point 0.4 divided by 23.8, it is coming 0.016. This is the relative lowering. This much vapor pressure is getting decreased. This is the relative lowering vapor pressure. This answer they did not give in the answer sheet. Only half they have given. So leave it. This will come. Okay.
Yes.
If we solve the some more problem, it will be clear. Now let us move out the next question. One more question I'm giving you. Okay, now see this question. What is this? Question they are saying, if 3 gram urea was dissolved in 45 gram water, the relative lowering of vapor pressure will be, how much it will be there? Can you calculate this?
Just checking.
Okay, see, I am doing. Okay. So that is they have given W2 how much? 3 gram urea. So M2 equal to this is 60 gram. Dissolve in W1 they have given 45 gram. M1 that is what will be there, M1. M1 will be, how much will be there? 18 gram. So that is this ratio they are asking. P1 naught upon P1 upon P1 naught is equal to this value they did not give. So directly we have to calculate equal to what will come. That is W2 into M2 divided by, divide, no, no. what I am writing. W2 upon M2 multiply by M1 W1. So this value they have given, W2 value they have given how many gram? 3 gram. M1 18, M2 60 and W1 45. Okay. Now this is the divisible. How much? 20 time. And this is 10 and here is 9. So 9, 5, 1 by 5, 1 by 5, 1 by 5, sorry, 1 by 5. So what is P1 naught minus P1 divided by P1 naught is equal to 1 by 500, I think coming, 1 by 500. So 1 by 500, if you are dividing 1 by 500, 0 0.002. See, somewhere we did mistake or what? 20. 20. Then we are dividing by 10, means 9. 9 5 ja 14. 5, 5, 5 na. So this is 50, 50, somewhere 50. So 5 to the 0 0.02. So the answer will be option A, 0 0.02, option A. 0 0.02. Can you check it?
Yes, sir. Then. Okay.
So this is the way to do. In the previous question, we are going a little bit moving to previous question, you see. If in this term, we can calculate this one also. Which term? In the term of this one, the same answer should come, 0 0.0168. This should come in the same form. So how can you do this one? Let us do now. I am doing here. P1 naught upon P1 naught is equal to W2 into M1 divided by M2 into W1. W1, W2 they have given 50. 18 divided by how much? 60. 850. So this would come same. To cancel out. I don't think 6 3 is 18. 30 upon 85010. So this is the 3 by 85. So 3 by 85. So 0 0.035, 0 0.035 is equal to 0 0.04. So can you see? No, 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 no. These values are coming different. But this should come same. Relative lowering vapor pressure, this value should come same.
Sorry, there are some deviation in the values, no?
This is deviation. Actually, the answer is not given. Okay, we have to check this one. I hope this should be correct. Okay. Because here we are putting the value. It should come same. It should come same. Let me
Value
check.
should come same. Otherwise, sir, method wise should not change, no?
To the 23.8 now. 0.4 divided by 23.8. Now I will check and I will tell you this problem. Little bit the critical one. Now go any other problem not there. Okay, I am sharing one more slides to you. Okay, so you solution and you go that one Raoult's law RLBP. Is it visible to you the slide which is opening one?
No, sir, it's not still loaded. I can see you are loading something, but still not loaded.
Now can you check? Now? Now?
Now, yes, sir, now it came.
Now it came. So vapor pressure lowering. Okay, vapor pressure lowering. Vapor pressure lowering means relative lowering vapor pressure. This is the, okay. So these are the little bit better problem. Now we can solve this problem. Question number 6, I am doing here. One question I am doing. Remaining you do. What they are saying, an aqueous solution of glucose is made by dissolving 10 gram glucose. 10 gram glucose means W2 is equal to 10 gram. M2 is equal to how much it will be there? 180 gram per mole. Okay. In 90 gram water, 90 gram water means W1 is 90 gram and M1 is equal to 18 gram per mole. Okay. Here they are saying at 303 Kelvin. If vapor pressure of pure water is 32.8, so P1 naught is equal to 32.8 mm Hg. What should be vapor pressure of solution? So P1 they are asking. So can I do this?
Yes, sir.
P1 naught minus P1 upon P1 naught is equal to W2 into M1 divided by M2 into W1. So P1 naught is how much? 32.8 divided by the minus P1 and again 32.8. Here it's again going to be how much? 32.8. This is again going to be 32.8 is equal to W2. W2 is 10 gram. M2 is 180 multiply by M1 18 gram. M1 W1 is how much? 90 gram. So this is going to be 1010 divisible 18 cancel out 1 by 90 is coming. So let me do here. You keep on checking the problem, na? It should not get mistake. So 90 32.8 minus P1 it is going to be equal to 32.8 only, right? Now we are going to multiply these
No,
things.
no, no, sir. 32.8 by 90. This is also
This is
correct because
cross multiply now. Cross multiply. Now is it okay? Are you getting?
yes, sir. But
90 multiply by 32.8. It is going 2952 minus 90 P1 is equal to 32.8. So here 2952 minus 32.8 equal to 90 P1. This is there. Divided here if you are subtracting 32.8, how much is coming, Sanoy? 2919.2 is equal to 90 P1. So P1 is equal to 2919 by 2 upon 90. So if you are divided by 90, 32.43. 32.43 mmHg. See the answer here. Are you getting this?
yes.
In the book, they solve very differently. See how the formula they are modifying. What they have done.
Lot of changes, sir.
A lot of changes they have done. Na? Okay,
Yes.
leave it. Why to understand, not necessarily. Okay. Now see. I
Sir,
will
but
say.
same only, sir. If we check the solutions properly, we will see that this is same only. You see,
Ah,
sir, here same only because if you take LCM, it will come this side, and this side just M1 and M2, you take in the opposite sides, and it will be all right.
acha, yeah, by taking LCM, na LCM they taken, so this is become 1 and
Uh,
P1 minus P1 not.
because this one
So,
just instead of using
uh,
product, they're writing in the division form. So this will
may,
come down here, and this will go up here. Same
little
only.
bit calculation portion will become easy. This portion, this will become easy by LCM. Remaining
Uh,
is as it is. Remaining is, I think, as it is. Remaining is as it is, no? Remaining.
so this part will be difficult here
Uh,
also.
okay, okay. Now understood, no? Now let us move out the. Let me check one more problem. This problem I'm giving you, but I am not showing you solution. And now you do this one. Here you can do 7-1.
So this
They are
is
saying
so
5
fast.
gram compound A was dissolved in 100 gram water. The vapor pressure of solution was found to be this one. P1, this is what P1, kilopascal. If the vapor pressure of pure water is the same one, kilopascal, at the same temperature, what is the molar mass of A? Can you do?
Trying, sir.
See, everything is the same only, but you need to know that is respective value. Which one is the pure P1 not and which one is P1 that you do. So what you do, you solve this problem and I'm going to drink the water. Okay. So you solve. Can you solve?
Sir, I think I cannot.
Then let me solve. Okay. If you think you cannot, then the problem is solved by me. W2 is equal to how many? 5 gram. A compound dissolved in 100 gram water. M2 they are already said they are asking. W1 how much there? 100 gram. M1 how much there? That is 18 gram. P1 not. Here you see little bit. This they are saying the vapor pressure of the solution was found to be 4.16. P1 is equal to 4.16 kilopascal at the same temperature. Here 16. If the vapor pressure of pure water is 4.26, P1 naught is 4.26. Say what is the molar mass of? That is M2 they are asking. So what we can do here to solve this problem? Very simple now. P1 naught minus P1 upon P1 naught is equal to W2 upon M2 multiply by here is M1 upon W1. So what will be there? P1 naught. P1 naught is 4.26 minus 4.16 divided by 4.26 equal to W2 5, M1 18, M2 they are asking W1. W1 is 100. So you solve it 5 to the 20 times 9, 2 9 ja 18, 10 is equal to 0.9 by M2. Okay, here I am doing. If you are subtracting, it is 0, 1, so 0.10 divided by 4.26. 4.26 is equal to 0.9 upon M2. So M2 is equal to 0.9 multiplied by 4.26 divided by 0.10. So what the value is coming? Let me multiply. 0.9 multiply by 4.26 divided by 0.10. 38.34.
Yes.
38.34 gram per mole. Now you check this one. 38. Oh, M1. How much they are saying? 46.8. You read the question again. 8 gram of compound A was dissolved in 100 gram water. The vapor pressure of the was found to be 4.16 kilo. Vapor pressure of pure water is now 4.24 is there, son. 4.24. 4.24. See, 4 point.
Yes,
Vapor
it
pressure
said
of pure water. 4.24. 4.24 minus 4.16. So, little bit again error I did here. So, this part is correct one. Only here I did mistake. So, what will be there? 4.24 minus 4.16, 4.16, 0.08. 0.08 divided by 4.26 is equal to 4.26 not here 4.24 every time doing mistake. So 0.9 of
4.24.
M2. So M2 is equal to 0.08. M2 is equal to if you are solving this one. So what we can write 4.24 multiplied by 0.9 divided by 0.08. So 4.24 multiplied by 0.9 divided by 0.08. 47.8. 47.8 gram per mole. So if you are little bit missing now, little bit missing means it will become the havoc and it create all the mistakes because the answer will come nearby, but that is the not correct answer. 47.8. You know, you check this one here, 47.8. So 46.8. Still problem. 46.8. My one is 47.8.
Sir, probably we have done the mistake in some addition or carrying over, I think.
No, 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 sub all correct only. Maybe the problem in the book also it can be. You see, they are doing in very big calculations. We are doing very simple one. Here you can see these calculations.
I'm checking, sir. I'm
Huh.
checking, sir, in the calculator. I'm checking also.
Okay, you check on later on and let me know because it will take too much of time. There are many more problem are there. Now you do this one.
Sir, there is one problem, sir. If you scroll up, I can tell you. Sir, because their value was there.
Huh.
So here what they are doing is M1 is 374.4 by something they're doing, and here it is coming 3.816. 3.816 by 0.08. So that means where they are getting 374.4, we are getting 381.6. So here problem is this place, this one,
Okay, okay.
this one.
But I think they have done mistake.
Might be.
Okay, now you do the another one. Why to waste the time unnecessarily? Okay, this question you solve. Okay. You are having the 5 minute of time. You do this problem by yourself. Okay, because I did almost 5-10 problem over. Now you are your turn. You solve this one. Getting?
So I'm not able to get actually what to do in these problems. That is the main
My
problem.
God, you read the question, yeah. They are asking calculate molar mass only.
No, means sir, which value is which one in that thing? Molar mass of solute, okay. Solute means a two number, na M2. We have to find.
Ah, see, I am writing here 1 gram non-volatile solute. So what is W2 na? Solute they are talking means W2 1 gram. In 100 gram of acetone, 100 gram. So W1 is there
W1,
100 gram. 100 gram. So obviously M1, what is the acetone? CH3, CO, CH3. Already molar mass they have given. How much they have given? 58 gram per mole. Okay. The vapor pressure of solution was found to be P1 they are talking about 192.5 mmHg. Calculate the molar mass of this one. If they are saying vapor pressure of pure acetone is 195. So here is one more point
other
is
I
there.
can do, sir. Other I can do. You just keep the screen like this.
P1, wait. P1 not is P1 not they have given now. P1 not is how much? 195. Is it? Is
Yes.
it okay? 195. Now any other information is there? No, that's much
No,
information.
others are not required. Also, I'm doing so.
Okay.
You
So
just please
do
read
it.
the screen like this.
Okay, you do.
Hmm. Nah,
I'm teaching now. 1.8 gram urea. How much coming? 45 point. This is
Yes.
okay, but where to check this one? This is the previous year questions. Okay, and solution is probably not there in this one.
Sir, will you
Acha,
give
yeah, is there 45. See the question. So
answer
you
my is
under
45, sir.
so that is correct, na? Round figure.
Yes.
45.73 is coming, 45.24 your. That is okay. This much can be considered here. So I think you understood this topic properly. Can you do one more?
Yes.
Okay. Do it. Do it.
So we are order 35%.
Hmm.
Water is a solvent.
Hmm.
You want this one? You want it? Sir, done.
How much is coming? 181. Let us see how much it is coming. 177 is coming somewhere. Have you done the round figure or what?
Yes, sir, yes, sir. 31.882.
Okay, that is why I think.
Sir,
177.
excuse me, I have a doubt. Sir, what they're using this formula, sir? I don't understand. This one.
Acha, they actually, what they have taken here, they did not delete this one. Moles M1, M2 value, N2 value, they did not delete. N2 value, this is mole fraction now. This is mhm. It should be X2 actually. Hmm. Okay, they did, I think they did it wrongly. Okay, don't worry for that one. Why they, because it is depending on the mole fraction of solute. So how they are writing this one? Acha, 27 gram. If you see the value, 27 is the solute or solvent. W2. Okay, formula they wrote wrongly, but the value they kept same. 27 gram. Can you see? You also place the value similarly, 27 upon 100. Okay, so 27. Similarly, in this one, although they consider W1, but the value you see value, they are taking the same. 27 upon M1. Getting this one?
Yes, sir.
Means one they probably consider this one they have considered in this book. Because this is the problem for second book. Why your value is coming more and this value is less? Because N2 they are not taking, they did not cancel this one. Because we are considering this one, N2, we are considered this is very, very low. Then the N1. So in denominator we are neglecting now. So your value, this in the book it is coming less because denominator is more. That is why. But don't worry, this is okay. Now next one, I am giving you one more.
Sir, what I have written, this is not going from here. Sir, you please remove this.
That will go. I will do. Here they are saying vapor pressure of pure water is this one, and the aqueous dilute solution urea is 22.9 mmHg. Calculate the molality of the solution. This is a little bit tough. Calculate molality of the solution, mole per kg. Density they did not give. How to calculate the molality? In the term of vapor pressure, they are asking to calculate the molality. Wait here. This is mole fraction they have found it out. And then they are X urea already there. So they are calculating this one M, this
Sir,
value.
that one, this, sir, question once more, please.
Oh, wait. I'm showing you this one. This. Yeah, that can be found. That can be calculated. Okay, that can be calculated. Question is this one. This one. The
Now let
vapor
me read
pressure.
23.76 mm of Hg and the aqueous dilute solution of urea
Hmm.
is less than 22.98 mm of Hg
Hmm.
and calculate the molality of solution.
Hmm. So first of all, you need to calculate the mole fraction of urea. So it will come by this formula. See, P1 naught minus P1 upon P1 naught is equal to X2 will come automatically because this is all the value they have given. X2 urea will come. How? 23.76 minus 22.98 divided by 23.76 is equal to what is there? X2. So if you are solving this one, let me do this one. You can also do this one, no problem. Little bit you need to use the mind. 23.76 minus 22.98. So it is coming 0.78 divided by how much? 23.76 is equal to x2. So this one divided by how much? 23.76. It is coming 0.032 is equal to x2. So this is the urea you got. Here also you can see in the book, in this one, how much they are getting. This value, they did not calculate actually the urea from Raoult's law. Urea they should calculate now. Directly they are plugging the values here. This one, 0.78 divided by 0.78 divided by 23.76. So this is same coming now. 0.032, what we are getting. 0.032, this one, but they are doing little bit difficult method. So now x2 x urea is equal to what you can do, that is n2 divided by n1 plus n2. Yes or no? So x urea is equal to, if I will consider to be number of moles of solute per kg of the solvent, per kg mass of the solvent, per kg mass of the solvent. So here, if you see N2, let it be N2 as it is. Urea is there. Urea number of mole. Okay. So let it be N2 only. N2. This value. And here is N1. N2 plus. N1 value how much? 55.5 moles of water. It will be the same now.
Yes.
So here you see what we can do here. If you are solving this one, total if you x urea is 0 point, it is coming 0.32 is equal to, this is N2 upon N2 plus 55.5. So N2 is equal to, if you solve 0.032 in bracket N2 plus 55.5, this is there. So if you solve, so 0.032 N2 plus 55 multiply by what? 55.5. So how much is coming? 1.821. 1.821. This is there. And this is N2. So let's subtract this one. N2 minus 0.032 N2 is equal to 1.821. This is there. So here N2 is the common. N2 is the common. So 1 minus 0.032 is equal to 1.821. So it is 1 minus 0.032. So here is N2 into 0.968 is equal to 1.821. So N2 is equal to 1.821 divided by how much? 0.968. So 1.821 divided by 0.968. 1.88 molar. 1.88 mole per kg solvent is there. 1.88. So see, this same answer is coming. This mole is there means and mass of water, how much is there? 1000 gram. So this is molar. Can you see this one? Can you understand? This is a little bit tricky one.
Yes.
Can't you understand this?
Yes, sir.
Okay. Now see this question. Vapor pressure of pure water. This one
Sir, but
non-volatile.
can you show the upper part of the solution? What is solved?
Where? This one.
Big. This one. Yes, this
This.
one.
Okay. Are you writing this one?
One second. Done. So done.
Done. All done or the anything missing here?
No,
Anything
nothing is.
nothing missing. Then what is the problem if you solve this problem then? This problem. Will you try?
Sir, one more you do, sir, after that.
Why I should do? I
Yes,
did
yes.
many. It can be done.
This
It
type
can
is
be
not
done.
clear.
What it is not clear? You read the question. It will be clear automatically. You can do.
Vapor pressure of pure water 40 mm, and
Hmm.
if even vapor pressure of water is
Hmm.
40
Vapor
upon
pressure
50.
of pure water. So P1 not they have given how much? 40 mm. If non-volatile solute is aged, its vapor pressure falls by 4 mm. So P1 will be its fall by 4 mm. So it will come 46 mm. 46 mm? No, 36 mm. It falls na. It's fall by 4 mm. 4 mm means we have to subtract 4. So it will be how much? 36 mm. Right. So solution is 36 mm. Calculate the molality of solution. Molality. Can you do this one? The last question same. This much tough problem will not come. This is the NEET type or the JEE problem is there. But should I do this one? Should I do?
Yes, sir, you do. You do.
Okay. Okay. If you are saying then I have to do. So P1 naught minus P1 upon P1 naught is equal to X2. So 40 minus 36 upon 40 is equal to X2. So 4 by 40 is equal to X2. So how much will come? 1 by 10, 0.1. Yes or no? Yes or no? Yes or no?
Hmm.
Hello?
Yes.
So what is there? If I will write x2 is equal to n2 divided by n1 plus n2. This is what is the vapor pressure of water they are talking now. So what is problem? X2 there is 0.1 is equal to n2. Let it be number of mole we required now. Number of mole per kg of solvent. So n1 is the 55.5 plus n2. Right. So now you can solve it. 0.1 here is 55.5 plus N2 is equal to this is N2 only. So here if you are multiplying by this one, so it will come 5.55 plus 0.1 N2 is equal to N2. So 5.55 is equal to N2 minus 0.1 N2. This is there. 5.55 equal to 1 minus 0.1 and this is n2 this is there. So what is 5.55 is equal
This
to
is approximately 5 by 9. 5 by 9.
I don't know what you are saying. Let me
I
check.
am saying N2 is approximately 5 by 9.
1 minus 0.01 so 0.99 na 0.99 n2 I am solving fully. So N2 is equal to what? 5.55 divided by 0.99. 5.55 divided by 0.99. 5.6 is coming. 5.6. 6 molal. That is per kg of solvent. So you see here answer how much is there? 5.6. How much? It is the more they are saying. What can be the problem here? Hmm? How they did? They have done this one. P is equal to P1 not X1. This one XA 0.9. But they have taken 0.9 only. Okay. So zero vapor pressure of pure water is this one. Okay. When non-volatile solute is added, its vapor pressure fall by this one. So this one we have done the reverse one actually. We have done reverse one. What the problem? Can you get the what the problem we are doing?
I think I can get because
We are putting the value of some different one. We are putting the value of different one. Because initial case is water is there na. Initial one is water. So we cannot add this one. For this one, vapor pressure of pure water is there. This one. Here up to mole fraction is there is no problem. Up to mole fraction there is no problem. But here is x2. So x2 value, if whenever we are writing x2, so n2 it will be, what is there? Vapor pressure of pure water, this one. If the non-volatile solute is added pure, all right, calculate the molality. So this one, n2 is there. Okay. And n2 we are considered to be solute, 55.5. But this is mole fraction of water, no? Mole fraction of water. Can you get this one? Mole fraction of water. Are you getting this one? Mole fraction of water.
getting.
But what is required? We required mole fraction of solute, na? What is the
Sir, we
molality?
can easily find out this method from here.
Mole. What?
So this one is shorter.
Huh. So no. Actually, what is the molality? Molality is mole per kg. Mole per kg solvent. Moles of solute per kg solvent. What the fraction we are getting? Mole fraction of water we got. What is required? Mole fraction of solute is required, na? So
Yes.
x1 plus x2 is equal to 1. So
Yes.
we required this one x2. Here, if you see this one we can consider to be. Okay, you consider that is x1. X1 is 1 minus 1 minus what I am getting here 1 minus 0.1. So x1 is equal to 0.9. This is there. Now keep in mind
What I was saying is
this
that,
is
instead of doing it in all this much number of steps,
hmm,
this much, it
uh,
could be much faster if we could do it by this way. This is looking more fast.
fast but understanding problem na understanding also important na. Uh, that you can do. There is no problem. Once you solve the problem, it will automatically you will be. So x1 solute is equal to n1 divided by n1 plus n2. Now x1 is 0.9 is equal to n1. N1 they are asking. And here is n1 plus 55.5. So now you can do here. So what is n1 is equal to 0.9 n1 plus 55.5. So what we can write? 55.5 multiplied by 0.9. So 49.95. 49.95. So here is, so 1 minus 0.1. 1 minus 1, sorry, 1 minus zero point 0.9. So 0.1 N1 is equal to 49.55. So how much is coming here? So N1 is equal to molality. Yeah, N1. N1 plus 55.5. You are solving this one, 45. This side it comes 0.1. What is the problem? It's not coming correctly. because you are dividing this one 49.5 divided by 0.1. It is coming 495. This is something wrong. This one, this method is we are not getting this one. Somewhere it is missing. Here you see x1, they are xa, they have considered this one. So m is equal to xb upon 100 upon xa upon ma. This one is there.
They're doing the molarity directly. Next, been target externally.
They are using this one. They are using the formula of molality. Here they have taken 100. Then they are doing like
1,000.
that.
1,000.
Huh. Here it is 1000, then 18. This is water. So if you are dividing this one, our is also coming same now.
Yes.
Our is also coming same. But in this case, it is coming in the numerator. Our is coming in denominator. That is a problem. X solute is equal to N solute. This is the solvent. So no, I'll check this one. Little bit it is critical. Okay. Remaining problem, what you do, these all the problems are there that you will be able to do. I will share the PDF if you want to solve this all are. Okay, there are many more problems are there. You can go. Maximum problem are there, 50 problems are there. So what you do, I will share you. You try to solve most of them.
Yes.
Okay, and if anyone is missing, you can let me know. Right. So that's all for today because tomorrow we are having the classes also.
So
So
tomorrow.
tomorrow your school is starting or what?
No, sir. Tomorrow I'm having practical exams in school. Physical education practical is there.
Okay. So you need to do some homework also.
Sir, you got to know anything about that November exam, board exam one, two times?
No, till now, no, yeah. April month it will come.
Yes,
It
sir.
will come in the month of April.